Alright guys, so on this video I'm going to talk about Simpson's rule, which is another approximation rule. Okay, so first I'm going to give you the idea. The idea is that, okay, so you have this function here, okay, and then you have this polynomial here, which is a polynomial degree 2 or less. So it's going to be a parabola or it's going to be a straight line. Okay, and then you have these 3 points, okay, the intervals here. It's just like the trapezoidal rule. So you have like xn minus x0 divided by n. You're going to have all these intervals around here, okay, and there's going to be another one and another one until you get to the end. Okay, so the idea is that you're going to make a parabola go through the 3 points, well, just 3 points exactly that are how can I say, that the function f go through 2. So the function f goes through this point, and this point. And for the 3 points, only 3 points, okay, because you're just getting 3 x's here, you have x0, x1, and x2. So for these 3 points, you want the parabola and the function to go through them exactly. Alright, so the point is f of x0 has to be equal to p of x0. What is this p? It's this one here, it's this function. Okay, and then you have f of x1 is going to go through p of x1. It's going to go through the same point. All the other points differ, okay? You can see that there's an error here. You can see that there's an error here. All over, it's not the same. But in these 3 points, it has to be the same. Okay? And you have f of x2, which equals p of x2. When you go to the next interval, you're going to use this x2 again. So it'll be like, let me undo these things here, because there's a limit to the undo feature. So on the, see, that's what I'm saying, f of x2 for the next interval, well, actually you have sets of 2 intervals. You have 2 interval sets. So for the next set, it's going to be, the first set is x0, x1, x2. And x1 has to be exactly in the middle of x0 and x2. It's got to be the midpoint. And then you have the next set of 2 intervals, which is 2, 3, 4. And then you have the next 2 interval set, which is 4, 5, 6. And then 6, 7, 8, 8, 9, 10. Right? So for the second 2 interval set, let me see where I am here. F of 2 is going to have to be equal to p of x2. F of x2 is going to have to be equal to p of x2. F of x3 has to be equal to p of x3, and f of x4 has to be equal to p of x4. Okay? This is the Simpson rule. Now, the more ends you're going to have, because this thing right here, look at the size of this. Look at the length of this interval. It's very big, it's very exaggerated for you guys to, how can I explain this, for you guys to see. All right, but try to imagine if instead of being here, this line instead of being here, it's over here. And instead of this line being here, it's over here. Imagine that these things are very tight together. The more you pack them, the closer you pack them together, the more P is going to approximate F. Okay? And then all you got to do is to sum all the 2 interval sets. Okay. So first, they came up with this thing here. They got a p of x, which is a quadratic formula. Okay, when you integrate, you come up with this formula here. Now, here you got to pay attention to a few things. What is this? Okay, it's going to be b minus a divided by 6. That's fine. Okay, this b minus a is actually the distance from xn minus x0. So it's going to be well, actually, it's actually b minus a. This is something very confusing for people that are beginning this now. This b and this a here are actually going to turn into x0 and x2. Okay? Yeah, I know it's very confusing, but it's going to turn into x0 and x2. Anyway, when you integrate from a to b, don't worry if a is x0 and b is either x2 or xn. Don't worry about that now, okay? But you have b minus a, you have the limits of integration, b minus a divided by 6, and then you have the p of a. What does that mean? Well, you see, after you integrate, you're over here, right? I'm talking about this part here. You integrate, and it's going to be ax squared divided by 3 plus ax cubed divided by 3 plus bx squared divided by 2 plus cx, right? And then you, instead of, what are you going to come up with in here, in this part to this part, okay? You're going to have a b cubed, all right, and then you're going to do all those things divided by 3, blah, 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 and then you have the second limit of integration. It's going to be minus a cubed divided by 3. So when you factor out the a, you have b minus a cubed, I'm sorry, b cubed minus a cubed. That's what you have. Okay, and that's where this thing in here is coming. So you're going to have to do a lot of rearranging, all right? I'm not going to do this here, but you have to do a lot of rearranging to get from here to here and to here, all right? And then what are they doing in here? Well, you can see that you have a b minus a here, and then you have a b squared minus a squared. Now this b squared minus a squared is the same thing as b plus a, b minus a, all right? And when you get one of these, this b minus a, you get b cubed minus a cubed. You do this long division, b cubed minus a cubed, and you divide this by b minus a, you're going to come up with this thing in here, okay? This is going to show up, a squared plus ab plus b squared. So that's where these things are coming from, because the book is not clear. Okay, how does it come from this thing to this part here? All you got to do is rearranging. But from this part to this part in here, what do they come up with this thing? You know, the 2a times a squared plus ab plus b squared. Well, that's how they come up. Actually, you have b minus a in here. You have b minus a hidden in here because it's this is b plus a, b minus a. And you also have b minus a hidden in here. Okay, if you do b minus a times twice, I guess, or maybe just once, I don't know, a squared plus b squared, you're going to come up with b cubed minus a cubed. So you have b minus a everywhere in here. And that's why here you have a 3, in here you have a 2, so taking a minimum common denominator, you're going to come up with a 6, okay? And they factored out the b minus a. So when they factor out b minus a, so this divided by b minus a equals this, all right? This second term divided by b minus a equals this term in here, okay? And the third term, this one divided by this, you come up with this. So that's what they did. Now, you're going to have to multiply this out, okay? So you're going to have to multiply it out in here, and then you have to multiply in here, and then you got to multiply it in here, you got to multiply in here. So after you multiply all the terms and expand this whole thing and rearrange them, you're going to come up with this thing here, okay? I'm not here to show you how the book does all this. I'm just here to show you the idea, right? So why is this P of A? It's P of A because look at this formula here. Let's just say that you put an A here and you put an A here. So it's going to be A squared. You got A squared in here. You have BA in here. You have C. All right? So if this is the P of X, this thing is the P of A, and this thing here is the P of B, okay? And then you have A plus B divided by 2. A plus B divided by 2 is just going to be the midpoint. So if A is X sub 0, b equals x sub 2. The c point, this point right here, okay, which is a plus b divided by 2, is just going to be c equals a plus b divided by 2, which equals x sub 1. Okay, so you can see that I gotta keep on doing these things as soon as I do them, because otherwise I'm not gonna be able to undo them all. So this point right here is gonna be xa, or well, it's gonna be a. This point right here is gonna be b, and this point right here is c. Now for the next two interval subset, okay, then x2 is gonna be a. That's why it's confusing. x3 is gonna be c, and x4 is gonna be b. Okay, and then for the third two interval subset, x4 is going to be a, x5 is going to be c, and x6 is going to be b. So you have a lot of a's and b's, and you got to be careful. Okay, so you have this thing here. Let me see if it's already time for me to. Oh yeah, and you can also see that there's a coefficient of 4 here, so you can see that this coefficient is 1, this coefficient is 1, and this coefficient is 4. Okay, but also when you plug it in the formula, well, okay, for now it's going to be fine. So you got a 1 here, you got a 4 here, and you got a 1 here. So you see that the coefficient is going to be yeah, for this I'm gonna do it down there. Yeah, it's better explained in here. Okay, so let me try to explain this part, and then I'm gonna explain where these coefficients come from, but it's just a pattern. Okay, so you have the integral here of f of x from x0 to x2. You see that it's not from a to b in all of it. Okay, it's just from the beginning of the set to the end of the set, and then you go from the beginning of the second set to the end of the second set, and from the beginning of the third set to the end of the third set, and these sets are always of two intervals. There's something else too. Here n's gonna have to be even, okay? So n's gonna have to be, for example, 4. So it'll go x0, x1, x2, x3, x4, okay? So you're going to have the first set of two intervals, which is going to go like here, and then you're going to have the second set of two intervals, which is going to go like here. Now, you see that the coefficient here is 1, of this one is 4, and of this one is 1. Now, for the next set, this coefficient is 1, this one is 4, and this one is 1. So you can see that x2, this x2 in here is going to be used in this one, and it's also going to be used in this one, so it's used twice. That's where this 2 in here comes from. You guys see here? That's what I'm talking about, this 2, okay? Actually, it's supposed to be 1, 4, 1, but this x2 is going to be used in the next one, so when you add them up, 1 plus 1 becomes 2, okay? The next set of two intervals is going to be 1, 4, 1, and the next set of two intervals is going to be 1, 4, 1, and okay, that's enough. Okay, so what do you have in here? You have x0, which is going to be 1, and then you have x1, which is going to be 4, and then you have x2. But here, this is x2, and this is also x2. So when you add them together, you're going to have 2x2. And then you have, okay, 0, 1, 2, 2, 3. Okay, so this is x3, which is going to be 4. And then you have 0, 1, 2, 2, 3, 4. Okay, this is going to be 4. Okay. This is x4 right here, which is going to be once, but x4 is also being used in here. It's being used in here. So 1 plus 1 actually becomes a 2. Okay, it's like this, guys. F of x0 plus plus 4 f of x1 plus f of x2. That's in the first two interval set. But in the second two interval set, you have f of x2. So you can see it's used in here once and it's used twice, plus 4 f of x3 plus f of x4. So the very last one is going to have a coefficient of 1. The first one is going to have a coefficient of 1. but this one is 1 and this one is also 1. You add these ones together and you get a 2. That's why the pattern is going to be 1. If it's just one set, 1, 4, 1. If it's 2 sets, it's 1, 4, 2, 4, 1. If it's 3 sets, it's 1, 4, 2, 4, 2, 4, 1. So you can see that it begins with a 1 and a 4, and it ends with a 4 and a 1. Okay, you cannot do this 1, 4, 2, 1. No, that's not the way it works. It begins with a 1 and a 4, and it has to end with a 4 and a 1. Okay, so it's 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2. Can we end here like a 1? No, the second to last has to be a 4. So you go once more, 4, and then you get a 1. These are the coefficients. Okay? There are more things that I have to explain before I go here. I'm going to erase this. Let me see here. Yeah. Now there's something that I want to explain about this thing here that's not so clear. So you're working about on the first interval here. Okay, it's very small. I don't know if you guys are going to be able to see this. No, so it's, oh man. I'm talking about this thing here. So it's the integral of x0 all the way to x2 of f of x dx, which is an approximation of the integral of px dx from x0 to x2. Okay, so remember what you had? You have a 2 interval set, because in the trapezoidal rule, every set was made of just one interval, but now you have sets of 2 intervals. You don't work with just one interval. You have to work from x0 to x1 and x1 to x2. You have to work with these together. And then from x2 to x3, x3 to x4, you have to work with these together. Okay, you cannot do, oh, I'm just going to do x2 to x3 and I'm going to forget from x3 to x4. No, you pick up every 2 sets. So the first and the second, the third and the fourth, the fifth and the sixth. All right. So you have this thing here. So what's this going to be equal to? Well, according to this formula here, all right, is going to be equal to x2 minus x0 divided by 6, right? So you have x2 minus x0 divided by 6. And then you have the formula, right? P of x0, which is the first point, plus 4p of x1 plus p of x2. That's fine. But here's the complication. How do you do this? How do you do? We're talking about two intervals, a set of 2 intervals divided by 6. Well, in order to get an interval, you get xn minus x0 and you divide it by n. This is going to be one interval, and then you multiply it by 2. Okay? So actually, they're considering here b to be xn is going to be the last point, and a is x0. So how do you do this? You do b minus a divided by n. But you also have to divide it by 6. Okay? So you got to put a 6 in here. But this b divided by n is just one interval, but you want to have a set of 2 intervals. So you got to multiply this by 2. And simplifying, this becomes b minus a divided by 3n. So in the trapezoidal rule, the term that was factored out was b minus a divided by 2n. Here's b minus a divided by 3n. Okay, and that's why you have this b minus a divided by 3n in here. And then you have this, oh yeah, there's something else too. You guys can see that it goes from p0 to f0. And the book doesn't make it clear why. But you remember what I said? That, look, I'm going to show you this thing here again. Okay. The 3 points have to be exact. Okay, so P0 equals F0. That's why the book jumps from x0, from Px0 to f of x0. Because the 3 points here, f of x0 is the same as P of x0. Here, f of x1 equals P of x1. And here, f of x2 equals P of x2. That's why the book jumps from one to the next. See, it's using p here. Look, f of x is an approximation, okay, of p of x, and then it's using p of x in here, and then it's using p of x in here, and then it jumps to f of x in here. And I was like, the first time that I saw this, I was like, okay, now what is the proof that p of x0 is going to be f of x0? Well, it comes from the definition of Simpson's rule in the first place. It has to be. And you guys are probably wondering something else too. You guys are probably wondering, like, okay, are you sure that a parabola is always going to go through the 3 points? How can we be sure of that? Well, pretend that this point was not here, okay? But pretend that this point was like here. Well, let me put it like here. Pretend that it was in here. What will be the function here? This function is still going to be the same, right? This function doesn't change, but this parabola now is going to change. Now you can make the parabola go through the 3 points. See, you can make the parabola start me here and go through that point and come up here. So always you can fit a parabola, doesn't matter what the 3 points are. They can be, oh yeah, and it doesn't always have to be a parabola. Simpson's rule says that you have to use the polynomial of degree 2 or less. So let's just say that this point, instead of being here, okay, the point was like, I'm gonna do this. So it's gonna be perfect. Let's just say that the point was here. Then you can just use a straight line. You don't even have to use a parabola, okay? Okay, so that's the theory of Simpson's rule. That's how you're gonna do this thing, okay? When you wanna approximate, you're gonna use, just to finish up, because it's very confusing, it's a lot of information, you're gonna be using this. So this is just, oh, okay, yeah, that's it. And then you go like, okay, but this is just an integration from x0 to x2. What about the second one? Well, the second one, you're going to do this again. You're going to do b minus a divided by 3n, okay? And then you're going to do like f of x2 plus 4f of x3 plus f of x4. So you're going to add this term, okay, to this term in here. Here I'm using p and here I'm using f, but you got to remember that for the 3 points they're exactly the same, so they can be added, okay? I can put an f in here, doesn't matter. And then you see this thing equals b minus a divided by 3n. It's the same thing. So I can factor the b minus a divided by 3n out, and I can just do f of x0, okay, plus 4 f of x1 plus 2, right? Because if you're just going to keep going, you don't end with a 4, you don't end with a 1. It's 2f of x2 plus 4f of x3 plus 2f of x5, 0, 1, 2, 3. Oh, actually, this is going to be 4. Okay, so 0, 1, 2, 3, 4. Okay, 1, 4, 2, 4, 2. The next one has to be a 4 because it has to end with a 4 and 1, not with a 2 and 1. So 4f of x, 5, and let's say that x6 is the last one, plus f of x6. Okay, so you're going to multiply b minus a divided by 3n by all this thing in here, and that's the Simpson's rule. And a lot of people that say, okay, well, let's just say that x6 was not the last point. Okay, we'll keep going. You have x6 in here, so you got to put a 2 in here because after 4 comes a 2, and then you have to have another 4. Okay, so 4f of x7 plus, let's say that x8 is the last one, so it's going to have a coefficient of 1, f of x8, and there you go. That's the theory of Simpson's rule. And now I'm gonna Now I guess I'm just going to show an example. Okay. So I'm going to use Simpson's rule again because remember it was the trapezoid rule, to approximate sine of x dx. Okay, now in my previous video when I showed the trapezoid rule, I showed that this equals 2. Okay, this is the exact thing. But when we do an approximation with n equals 4, now I'm going to do the approximation n equals 4. Okay, so what's going to be b minus a divided by 3n? Well, it's going to be pi minus 0, which is pi, divided by 3 times 4, which is 12. So it's going to be pi divided by 12. All right? And then now you want to get this pi divided by 12. And you want to multiply it by, well, you're going to have 4 things. So it goes from x0 to x4. Okay? So what's going to be the, well, let's do this. Oh yeah, and there's something else too. What's gonna be the delta x? All right, delta x is gonna be p minus 0 divided by 4 because n is 4. Okay, the delta x is b minus a divided. Well, this b minus a is actually, well, okay, fine. B minus a divided by n. Okay. Which equals in this case pi minus 0 divided by 4, so it's pi divided by 4. Okay, so it's going to be the sine of 0, right, because it starts with a 0, plus the next coefficient is a 4, remember? So it's going to be 1 in here, now you have a 4, sine of 0 plus pi divided by 4, which is the delta x is pi divided by 4, plus does it end with, this is x0, x1, x2? No, it ends with x4 because n is 4, okay? So we keep going, plus twice sine of 2 pi divided by 4, because you're adding, you have pi divided by 4 here, plus pi divided by 4, which is a delta x, 2 pi divided by 4, plus 4 sine of 3 pi divided by 4 plus the sine of 4 pi divided by 4. And that's it. Okay, this is going to be Simpson's rule approximation. So you can see that's 1, 4, 2, 4, 1. Okay, that's, the coefficients are right. And the number of terms, you can see that it's always n plus 1 terms, right? Because if it's going from x0, okay, let me do this here. This is x0, this is x1, this is x2, this is x3, this is x4. From 0 to 4 inclusive, you have 5 terms. So the number of terms is always going to be n plus 1. Okay, so if you do this approximation and multiply by pi divided by 12, the book says that you have 2.005. Okay, and for n to be 8, let's just say that you want to do this whole thing, but instead of using n4, you want to use n8. So this is going to be an 8. Okay, this is going to be an 8. This is going to be an 8. And here, if it's 8, okay, and instead of being this, it's going to be 24. So this one in here is going to be 24. And you're going to have these terms, but you're also going to have pi divided by 8, 3 pi divided by 8, 5 pi divided by 8, 7 pi divided by 8. All right, you have to add these. So besides all this, you're going to add like sine of 3 pi, well, of pi divided by 8, plus the sine, and you're also going to have to put the how can I say, the right coefficients in here. So the coefficients are going to change, okay, because it always has to be, it's not like in the trapezoid rule that it was 1, 2, 2, 2, 1. It's 1, 4, 2, 4, 2, 4, 2, 4, 1, something like this. So you have to put the right coefficient here, you have to put the right coefficient here, sine of 3 pi divided by 8 plus the right coefficient here, sine of 5 pi divided by 8 plus the right coefficient here, sine of 7 pi divided by 8. So when you add all these things and you multiply pi divided by 24, it gets even closer. Now it's 2.003. That's what you're going to get. Remember that I said that the exact answer was 2, so you can see that it gets pretty close. Okay. Simpson's rule is more precise than a trapezoid rule for the same n. Okay. Using the trapezoid rule, I just want to make a comparison here. We're going to have trapezoid rule and Simpson's rule here. And I'm going to show you guys something. So, and in here, I'm going to put an n. So we have something like this. I never know how to make these tables. Okay, I'm just going to do this here. Let me erase this mess in here. I'm going to put an n here, okay, for n equals 4 and then n equals 8. Well, we saw that for Simpson's rule, for n equals 4, the number that you're going to get is 2.005, which is pretty close to 2. For n equals 8, in the Simpson's rule is 2.003. Just as a reminder of what we got last time in the previous video, okay. Okay, so you see that for the same n of 4, Simpson's rule gets pretty close. 2.005 is very close to 2. Okay, 1.896 is a little bit further. So 2 minus 2.005 is just 0.005, right? Now 2 minus 1.896, I think is going to be 0.104. So you see that Simpson's rule gets a lot closer. This is the error for Simpson's rule for n equals 4, and this is the error for the trapezoid rule for n equals 4. Okay, so you can see that Simpson's rule is a lot better. It's a more precise approximation method. That'll be it, guys. On the next video, I'm going to show you the errors between, for example, a formula that's going to show you the limit of the error. It's not going to show you what the error is, but it'll be the bound of the error, the boundary. The error is never going to go beyond that. It's the worst case scenario, okay?